Chapter 27, we are going to talk about resistors, about Kirchhoff rules, something about voltmeters and ammeters, and the RC circuits. Let's go to start. Okay, when you have a resistor, you can arrange the resistor in series, or you can arrange in a way that all the resistors are at the same difference in potential. If you arrange in a way that all the resistors are in series like this one, they are not at the same difference in potential. The potential decrease is going from A to X, decrease in going to X to Y, and decrease in going to Y to B. But the current is the same. So, but in a resistor that are arranged in parallel, the difference in potential decrease in this direction, but they are having each one the same difference in potential. So they are having different currents because they have different resistance. So here is I1, here is I2, here is I3. What is the equivalent resistance for this arrangement? What is the equivalent resistance for this arrangement? If you have resistor in series, the equivalent resistor is R1 plus R2 plus R3. If you have parallel arrangement of resistors, the equivalent resistance is 1 divided by R equivalence, is 1 divided by R1 plus 1 divided by R2, etc., etc. Why is that? Let's go to explain this. Why is that? Okay, to understand why the resistance that is arranged in series is the sum of the two resistors, you have to take in account, first of all, that the current that is coming here is the same current that is going out. So the difference in potential V sub AV is R by I. The R, the equivalent resistance by I, by the current that is passing through this. So you have this equation, V sub A minus V sub B. V sub A is a higher potential. When you go, you decrease the potential R1 by I. When you go, you follow the way, you decrease the potential R2 by I. So you arrive to the potential V sub B. So V sub A minus V sub B is minus R1I minus R2I. So V sub A is a higher potential. Is the potential that exists at B minus R1I minus R2I. So V sub A is equal V sub V minus R minus R1 plus R2 by I. So V sub A minus V sub B is the difference in potential. The difference in potential divided by R is the equivalent resistance. So from this equation, I found that the delta V divided by the R, the equivalent resistance, is the current. Which current? This current or this current. So R equivalent, the R equivalent is R equivalent is R1 plus R2. Let's go to do it now in parallel. When two resistors are connected in parallel, the fundamental thing to pay attention is that the current going in is the same current going out, but it's not the same current that passes through every individual resistors. So the current I entering is I1 plus I2. The current going out is I1 plus I2, and is the final current I going at the end of the passing through the elements that are the two resistors that are in parallel. So the current I1 plus I2, it would be the difference in potential between the 2 points. These two resistors are subject to the same difference in potential V sub AV. So I1 will be V sub AV divided by R1. I2 will be V sub AV, the same one, V sub AV, the same, divided by R2. So V sub AV, that multiply factor common 1 divided by R1 plus 1 divided by R2, it would be I. If you compare this equation with the equation, a general equation of Ohm's law that say that the current is the difference in potential divided by R, so you can now see that 1 divided by R equivalent is 1 divided by R1 plus 1 divided by R2. And that's all.